So Pogo, so folks who don't know Pogo, Pogo is a casual games business. We're part of Electronic Arts, which is based right up the road here in Redwood Shores. And within Electronic Arts, we're part of the EA Interactive division, which also includes Playfish and EA Mobile. We have hundreds of free games that you can come and play on our website, all different kinds, a very active community. We make our money by selling ads and sponsorships to free users, but we also have a premium tier, our Club Pogo subscription. You can sign up and pay us monthly or annually. And for that, you get access to 40 or so exclusive games. You get enhanced community features and microtransactions, a separate virtual currency. We distribute our games online via destination site. We just recently announced Pogo for iPhone and Facebook and other third parties. We have about 11 million monthly active users total and about 1.5 million Club Pogo subscribers. And we have our users average just under about an hour per session, which makes us one of the stickiest sites on the web. So if you ever getting caught, playing one of these casual games at 2 in the morning, you're not alone out there. Lots of folks getting hooked on these things. So if you rewind the clock about 18 months at Pogo, everything we were doing was based on a traditional centralized IT infrastructure, which means there's a single shared project queue within the EA IT organization. And every project has to get into that queue. Every project at EA has to compete with other limited IT resources, right? And it might work fine for bigger projects, but for smaller projects, especially projects that you just want to get started on, you want to try something out, you're not really sure where it's going to go. It's a lot of fixed overhead. The other big problem we had was monolithic deployments. So a lot of organizations call these release trains. At Pogo, we call them a bus. I don't know why exactly historically it's known as a bus. I actually stole this graphic, shamelessly stole this from another presentation. Here's a graphic of the bus. And there's a little green guy on there with red hair. I don't know what he is exactly, but he's missing the bus. And you don't want to miss the bus, because if you miss the bus, you have to wait another full 2 weeks before you can get your feature deployed to production. So both of these things contribute to a problem internally where we have these hotly contested shared integration environments. So they're expensive to create and spin up. And the bus problem means that even at a smaller scale internally within the QA organization, you have very fixed deadlines and timelines when you can upgrade these environments. So for all these reasons and for others, the decision to leverage the cloud was really pretty easy. It was never a question of do we use the cloud or not. It was really a question of, okay, how can we get there? How can we get there faster? What we came up with, I guess I'd describe it as a tethered cloud, which is to say we have a set of core services which are still based within our IT infrastructure hosted at EA, where our persistence engine is an Oracle rack. And those core services, of course, have to talk to other EA services. And the hard work here is trying to identify what are those core services, how can I strip off the presentation layers, how can I make these services available to other services that are running up in the cloud. So I can start by creating all my new services, so like friend-based social game leaderboard, high-score leaderboard or something based on SimpleDB. I can put that up in the cloud. But these new cloud services are still always going to need to call back to a set of core services. So, I wish I had some great insight to share here with folks, but I don't. This is really hard work. It takes time. You definitely can start off by building all new services right up in the cloud immediately from the get-go. But identifying the core services and how you can separate them out and migrate them into the cloud is just something that takes a lot of time. We've had a lot of success doing it, and I think the pace at which we'll continue to do it will continue to accelerate going forward. But it's definitely takes time. One of the things I want to talk about a little bit to some of the more technical members out there was just how we automate deployment in general. So this is a typical problem, which is hopefully your development organization is already convinced of the value of automated builds. You have an automated build system, you have an automated unit test, you have all this, but you don't have a good automated deployment system. And so I've seen a lot of solutions to this that usually involve cobbling together some Perl and Python and other shell scripts or whatnot. What you end up with if you're not careful and you're not using a cloud and you're not using virtualization is you end up with a set of installation scripts that are unique to a QA environment where you're trying to get maybe multiple sandboxes onto one machine that are completely different than the processes you use in production. Because in production, you have a completely different set of machines. You have a lot of machines and they're specialized by function. Right? So there's a disconnect between those two processes and installation scripts, and there's a big gap, and problems fall in the gap. And a lot of times, unfortunately, you don't find those problems until right before you go to production. Maybe if you're lucky, you find them in a staging environment. So we want to try to fix this. We want to do better. We want to make this as consistent as possible. So this is an example of what we came up with. We decided we use Linux, and we use Ubuntu as a flavor of Linux. And we decided to deploy everything we do as an operating system level package. So Linux has already built into it a package manager. It's how the operating system itself gets all of its updates and upgrades. And it's just sort of blurring that line between an operating system and applications a little bit more. So you have this package. The package has a version number associated with it. And the package has a list, the Debian package, has a list of other things that it depends on. And those things that it depends on, they could be internal dependencies, like other code that your organization has written, or they could be external dependencies, like a particular version of Jetty or Java or whatever. It doesn't matter. We deploy all of these things as packages, and we manage this all consistently. So we start with source control, and EA uses Perforce. We pull this into our automated system using Maven and Hudson. And then we have these little orange boxes you see marching up to the cloud there. We put them on a service that we call Mothership. It's basically a Debian repository. And then we add external dependencies. So if I have like a Pogo web app, and it says, well, I'm a Java web app, I'm dependent on a Jetty, a web container, version 7, that thing might say I'm dependent on JDK, a particular version 1.6. All these dependencies are captured and expressed as Java as Debian packages. So ultimately, when you need to bring up a web node, you can do that at a particular version. You can just use the built-in OS installation commands and bring up a node at a particular type. And we use this consistently then across all our dev, QA, and production environments. One of the other things I wanted to mention was how we use RightScale monitoring. So RightScale has terrific monitoring capability. I think everybody here has hopefully seen it before and familiar with it. You can organize all your nodes into logical deployments and then into server arrays and then actually drill down into nodes within arrays. But one of the things that might not be as widely known is you can extend those capabilities yourself, and it's actually really easy to do. We use Java, and we have JMX as an endpoint. You just write a little integration script that talks to that endpoint and just ships that data to collectd, which is already running on these RightScale nodes, just right out of the box. And from there, it automatically gets to RightScale and gets to all those monitoring servers we saw earlier. Right? So just an example graph of this. This is a service where we have a daily special service, and getting the game that's special that day when you can win special prizes. And I can look at this and know, hey, there was a small anomaly that occurred at 3 in the morning. So this is very detailed information. You would never want to start with this, but the fact that you can organize things logically in deployments and then drill down to server arrays and then to nodes, and then within an individual node, get answers to questions to how that service is performing, both to callers of the service and what services that service is itself dependent on and how they're performing, is just a super way to organize information and monitor the system. So when I heard earlier how RightScale was improving this with heat maps and the stacked graphs, that was pretty cool. And we definitely would make heavy use of that when that comes out. One of the other things we're doing is improving analytics. So we use syslog-ng as a log aggregator. We use it to pull all of our logs into S3, and we add other logs that come from EA, and then we transform them, and we just put them into a form that's palatable to Hive. So Hive is a kind of new data warehousing infrastructure based on Hadoop. It supports a simple query language called HQL, which is sort of SQL-like. But one of the things it's really good at is working over very large data sets. So we use this internally for extensive performance and error reporting. And then we also connected MicroStrategy, which is a front-end sort of business intelligence tool to it. And we set up MicroStrategy to run batch jobs every day to provide new insights to the marketing department. So the key point here I like to make to folks is this is really easy to do. I mean, Amazon's MapReduce service makes this really easy to do, and Hive Hadoop is open source. So if you're not using the cloud already because maybe you have that tethered cloud problem I mentioned in slides 2 or 3, and it's hard to move large online services, analytics is a great way to get started. Start small. It's usage-based pricing. Explore where this can take you, and I think you might find it gives you some great new insights. The results of this at Pogo are terrific. I think they've been really good. I mean, our deployments are faster. They don't require any downtime for our cloud-based components. Our integration environments, we can have more of them because they're less expensive to create. We have that consistent build and deploy pipeline. It's all based on RightScale. It's all running in the cloud. It's the same, again, whether it's deploying a box to a QA environment, staging, or production. Rolling back is easy. It's the typical RightScale approved way of bringing up a whole new cluster for production and switching DNS to it. If there's a problem, you simply switch DNS back. Adding capacity is easy thanks to the cloud. The bottom line is the team is more empowered and it really enjoys this additional ownership. So I think it's an exciting transition for software developers. I think that it's really fun to see these software abstractions and keep raising the bar higher and higher in this industry. And the bottom line is it really works. So it's working well for us, and I hope it works well for you too. Thanks.